So these are the soil forming factors. Again, it has been divided into active soil forming factors and passive soil forming factors. In our previous videos or previous lectures, we have discussed about climate and we have discussed about soil biota or soil animals, plants and animals. We have discussed about these two active soil forming factors. Now in this class, we are going to discuss about parent material, which is coming under a category of passive soil forming factor. There are some points regarding soil parent materials. Let us see. In parent material, at such an extent, it has significantly influenced the soil characteristics during the initial stage of the soil development because of its passive nature. And the nature of mostly this parent material highly influences the characters like texture, which is a very basic property of the soil, which cannot be altered, cannot be altered easily. So texture cannot be altered, but mostly this parent material will influence the texture. And after, soil texture controls the downward movement of water, very important property. And this important property will affect the translocation of fine soil particles and plant nutrients, right? And mostly the role of parent material in soil formation is passive. There is no energy involved. So due to this passive nature, there will be a very weak correlation between the parent material and the soil formed from them. Okay, these are the some important properties. And few more points to remember. In initial stage, soil properties are mainly determined by the kind of parent material. So what kind of parent material will be produce what kind of soils, we'll see here. So basalt, we all know that extrusive igneous rock, it produces red soils coming under a soil order called ultisols. And again, basalt, we can see black due to the different climatic conditions. We can also see the black cotton soils. And in igneous rock, that too acid igneous rocks, we can see light textured podzolic soils formation will be very high. Followed by basic igneous rocks, opposite to acid igneous rocks, we can see fine textured cracking clay soils, mostly vertisols we can see in this type of parent material. Followed by basic alluvial parent materials. In alluvial parent materials, fine to coarse textured soils like antisol, inceptisols formation chances are very high. So these are the parent materials in this side, and these are the type of soils which are formed from the parent materials. So we all know that, and the correlation between the parent material and type of soils have a very weak correlation because of its passive nature. And a few more points to remember. The nature of the elements released during the decaying of rock or weathering of rock, whatever we say, have a specific role in the soil formation. So remember these points. Like first point, silica and alumina furnishes the skeleton for the production of secondary minerals. Very important point. Those, I think, if we have any idea on secondary minerals, like clay minerals, this aluminum octahedra or silica tetrahedra, which plays a skeleton for the production of secondary minerals. And iron and manganese are important for imparting red color to the soils and for oxidation and reduction phenomena. So we all know that if there is iron is there, red color formation will be there, and due to the manganese and iron, we can see oxidation reduction phenomena will be takes place in the soil profile. Followed by sodium and potassium are important as a dispersing agents for the clay and humus colloids. Remember this point. Sodium and potassium are considered as the dispersing agents, but more sodium have a very predominant role in the dispersing agents. That's why in texture analysis we used to add a sodium hexametaphosphate for dispersing the soil particles. Another important point, your calcium magnesium, quite opposite to above, calcium magnesium having a flocculating effect, resulting favorable and stable soil structure for a plant growth. Remember this point. So calcium and magnesium having a flocculating effect. These are called the flocculating agent. Calcium magnesium is called a flocculating agent. Due to these elements, we can see there is a formation of stable structure for the plant growth. Thank you.